So, very good evening to one and all. Very good evening to one and all. Thank you for your presence in our 30-day masterclass on advanced VLSI design and verification. So, very good evening to one and all. Thank you for your presence. Just a minute. So today, very good evening. Today we are gonna see coverage. Then tomorrow we are gonna see the AXI protocol code implementation. Why? Because of we are missing with the coverage. So it is also an important topic in SystemVerilog. So while doing the SystemVerilog architecture, we are doing randomization, we are doing constraint, we are doing assertion. Now coverage also a very important topic. It is also a very important topic in SystemVerilog. Today we are going to see this coverage only. So coverage, what is that, what is the coverage, what is the types of coverage, so how it is works, so what is the main purpose of coverage. So we'll see one by one in this today in this session. So very good evening and all. Thank you for your presence. Let's wait for a few minutes and then we will start the session. So we'll start with the coverage. So today I don't have any PPTs, so I have some notes here. This is my own notes for whole SystemVerilog, all the topics I'm having in my hand. So you will get this report also, notes. So it is a very simple note. So it having all the topics: coverage, assertion, constraints, SystemVerilog test bench architecture, and then basics of the SystemVerilog data types, and then blocks, procedural blocks. Okay, so we having all the contents in my notes. So today we are gonna with notes only. Okay, so we'll start from the coverage, definition of coverage. So SystemVerilog coverages, we'll start from here. I think it's visible for you. So coverage is why we are using coverage. So firstly I will tell by simple thing. So why we are using coverage means, so in SystemVerilog architecture we have a design code. To test the design code we are doing test bench, we are writing test bench code with the help of SystemVerilog architecture. And this architecture we are doing randomization, generating random inputs. So to limit the randomized data we are using constraints. Okay, so till now we are we have reached with the constraint only, constraint assertion. So constraint mostly used for to limit the randomization. Okay, to give the randomization range you can give by using constraints. Now coverages is why important means, so we have to check that. So we having doing randomizations, so whether it is covered or not. While doing randomization means, for example you are doing one signal, so you are doing randomization with one signal, like it will randomized between 5 to 25. Okay, 5 to 25. So literally it having the 20 words, 20 number of values we have to randomize. So our work is we have to check that, so whether that 20 values are randomized or while doing randomization that values are hitted or not. If it is hit means it's okay, our randomization works fine, so there is no issues. If it is randomizations are not hitted, the some values like 5, 7, 20, 21. So if any misses of randomization means it is an error also. It is a backward of randomization, backward of testing. Why? Because of I'm missing some values for I'm missing some inputs for my signal. Okay, randomized input for my signal. So we have to check that all the possible values are covered or not. So to check that we can use coverage. Okay, so this is a basic definition of coverage. This is why we have used the coverage to check the randomized signal whether the values are covered. So we can give the range by using constraint. So after constraints we have to check that, so that particular range values are covered or not. By using SystemVerilog coverage you can check. So coverage, it is a two types. It having the two types: code coverage, functional coverage. So we'll see one by one. So let's wait for a few minutes. So before going to that, so very good evening to one and all. Very good evening Bharata Singh, Vaishnavi PV, Naveen Rate, Kesavan. Very good evening. Thank you for your daily presence. Okay. So why today I'm skipping the AXI means tomorrow we will see the AXI implementation code. Okay, tomorrow is the final day. So why? Because of tomorrow we're gonna see the whole SystemVerilog test bench architecture, so a code for AXI. Why? Because of we have tomorrow we're gonna see AXI design code and also AXI test bench architecture using SystemVerilog. So it having the like a generated driver, randomization, coverage, interface, assertion. So we will see the complete test bench architecture for AXI protocol tomorrow. So for that we till now we didn't see in about SystemVerilog coverage. That's why I'm taking the today class is SystemVerilog coverage. Okay. So today we are going to see SystemVerilog only. So thank you for your presence. So we'll start now. So coverage. So coverage is used to measure the tested and untested portion of design. So tested untested portion means we are giving some stimulus, we are giving some randomized inputs to design code. If you randomize some values only, so there is a mismatch, there is a missing of remaining values. So by using coverage we can identify that. So by using coverage you can measure the tested untested portion of your design. So coverage is defined as a percentage of verification objectives that have been met. So that you have been met. So it having two types of coverage: code coverage, functional coverage. So code coverage. So code coverage measures how much of your design code is exercised. This includes execution of design blocks, number of lines, condition, FSM toggle. So these kind of number of blocks, number of lines, FSMs, toggle and path. This kind of code lines, code letter things, it's taken by tool only. So we didn't do so as a user we can't do the code coverage. Tool will automatically take care of the code coverage. So simulator tool will automatically extract the code coverage from the design code. Okay, so code coverage is not our part, it is our tool part, simulator tool part. Okay, so code coverage is taken by the tool, simulator tool. Okay, so and then coming to the functional coverage, it is in our task. So functional coverage is a user defined metric that user how much of the design specification has been exercised in verification. This is a main thing. So functional coverage means so how much of your design specification. So design specification is nothing but so we are working for chip making. So we each and every chip have a specific specification requirements. So we have to check that by using the SystemVerilog constraint, randomization, and then coverages. So this is a function of the functional coverage. So to check the functionalities of the your chip, okay, your chip for working. So this is a basic info of the functional coverage. So functional coverage is a user defined metric that measures how much of your design specification has been exercised in verification. Okay, so there are two types of coverages, functional coverages. One is data oriented coverages. Okay, another one is a control oriented coverages. Okay, here data oriented coverage means today we are going to see that only. So data oriented means we having the some cover groups, cover points, cross beans. We will see one by one in the what is data oriented coverage. It checks the combination of data values have occurred. So it means we are doing randomizations. If assume like I'm doing the 10 times of randomization for signal 4 bit of A. So it means 4 bit means where there is a possible values from 0 to 15. If I'm doing 10 times means there is a chance to I can hit the 10 values only, 10 values only out of 15 values. So 4 bit means it can give the 15 values from 16 values 0 to 15. So but I am doing randomization of 10 times, so I will get only 10 values. So this kind of 10, so my constraint also condition like that only. So from 10 15 to sorry 5 to 15 is my constraint value. So I will get only randomized value between the 5 to 15. So I want to check that if from the 5 to 15 it's heated or not. Heated means occurred while doing the randomization is occurred. If it is not occurred means this is a process of checking coverage. So if it is not if it is occurred means there is a 100% of coverage. If some values are missing, so some values are not occurring means it is known as off coverage. So we did only off coverage like a percentage, 50% of coverage, 80% of coverage. So coverage reports we can set by percentage only. 50% of coverage we got 100% of coverage. Okay, so coverage results we can say by the percentage values. Okay, so and then this is known as a data oriented coverage. So we'll see the control oriented coverage. Okay, it checks whether sequence of behaviors has occurred when we can assertion. So writing the SystemVerilog assertion is comes under the control oriented coverage. Okay, so we having the coverage, it having the two types: core coverage, functional coverage. In the functional coverage, it having the two types: data oriented coverage and then control oriented coverage. So data oriented coverage means we are going to see only like it having some specific syntax like a constraint, cover groups, cover groups. So we'll see one by one in the session. And then control oriented coverage is nothing but SystemVerilog assertion, SVA. So SystemVerilog assertion is comes under the control oriented coverage. Okay, so we'll see the defining the coverage model. So coverage model is defined using the cover groups. So cover group syntax, so it is an important thing, cover group syntax. So it having syntax like a cover group name and then end group. So inside that we can make a points, cover points. So cover group concept is user defined type, that the type definition is written once and multiple instances of the types can be created in the different context. It means we can create the cover groups and then we can make a multiple instance for the cover group like a class. Okay, so cover group is also similar to class. So each cover group specification can include a clocking event and that synchronizes sampling of cover points and then set of cover points, cross coverage between the cover points, optional so we'll see one by one what is the cross coverage, what is the coverage options, and then set coverage points. Okay, so and then so cover point is nothing but the cover group can contain one or more cover points. The cover points can be integral variable or integral expression. Each cover point is associated with the bins. So one on each sample clock simulator will increment associative bin value. So it means, so I will show you what is a cover group. So you can see here there is one module. So this example for the cover group and then cover point. Okay, example code for the cover group and cover point. So you can see here there is one module, it having the signals like a clock, address, write or read. Okay, these are my input signals. So clock is a single bit signal, address is a 8-bit signal, read or write is my single bit signal. So you can see here this is my cover group syntax. It will start from cover group. This is my cover group name. So in this is a cover group triggering element, so triggering signal clock, passage of clock. Okay, and then this is my cover point name. So C1 is my cover point name. So and then this is my cover point keyword. So why I am using cover point means I am pointing, so I am pointing, so the cover point is defining like a pointing some signal. So cover point, you can see here it is an address ADDR, so it is my signal. So I am pointing to, I am pointing the signal have to be covered. So that's known as cover point. So if I created the cover point means it will create the auto bins. Each and every time while doing randomization it will give some values. For example, for the address from 7 bit of 0 to 7 bit of 1, it means 0 1 2 3 it will go to 7 bit of 1s. So each and every randomization it will hit at least one value. So that one value we can represent as the bins. So for 4-bit means you will get the 16 bins. 0 is a first, assume like a 0 is my first bin, and then 1 is my second bin, 2 is my third bin. So up to 16 bins you will be that will be created by using the cover point. Without by if you literally lighting like a cover point and signal A means it will create automatic bins. Okay, up to it is fully depends on your signal width. Like 4-bit means you will get the 16 bins. Each and every values is like a bins. If it is randomized means you will get the percentage. If it is not randomized means you will get the 0%. Okay, so I will show you the output, then only you can easily understand what is literally like that. Okay, so and then there is my cover point cover point for my second signal, right, read and write. So I will just show you I will just write one code. So I will just write over here. So you can see here. I think it's visible for you. So I will close. Okay. So firstly, I'm creating one class. Class name is co cow. This is my class name, and then n class. I think it's visible for you. So here I'm using rand c keyword. I am creating signal rich 4-bit of 4-bit of signal. The signal name is ADDR. Okay, and then I'm creating another signal rand c logic. So here I'm going to use 2-bit of signal. It is a ID. Okay, so this is my signal, and then here I am creating the coverage. So for that we have to create the cover group, and then cover group name is this, my cover group name. Okay, and then end group. So this is my syntax. This is my syntax of coverage, cover group. So while writing the coverage means you can write inside my inside your cover group only. If you want to check the signal coverage means you have to create the cover group, and inside you have to create the cover point. So and then in the cover point you have to add some signal, then only you can check the coverage report. Okay, coverage report. So I created the cover group. Inside that I will create my cover point 1. So cp1, it is my cover point, first cover point. So cover point, so cover point signal name is ADDR. So it will automatically check the signal ADDR address. Okay, so till now I just did only this only. So and then I am creating the another signal function. Sorry, I am creating another function new to make the instance. So here also in the function in the coverage also you have to create the instance. Okay, so instance of your coverage. So how you can create the means, cg is my cover group name, and then c1 is my instance name of my cover group. I'm creating memory for that inside my new constructor. Okay, so and then this is my class, and then again I am creating the one module here. Module name is tb, and then end module. Again I am creating the handle. I'm creating instance for my class. My class name is cob, and then my class handle name is and h1. This is my handle h1, and then in my inside my initial begin simulation time. Initial begin, in my initial begin I am I am creating, so here also I am creating the memory for the class. Okay, I created the memory for the class. Here I am doing the repeat loop, repeat of I think 15 20 times, 20 times. Okay, repeat of 20 times. This is my repeat block. Here I am going to randomize. Okay, so for that I am just use my h1 instance name of my class and then randomize. Okay, I am doing randomize over here, and then at the same time I am doing a h1 dot and then c1 dot sample. So you can see here this dot sample is refers as, so h1 is my handle name of my class, c1 is my instance of my coverage, and then sample is my, I'm just sampling the coverage. If you didn't write this sample means you can't see the coverage report. So you have to write the dot sample to see your coverage report. Okay, so firstly you have to create the class and then add some signal with the RANC keyword, then only you can do randomization. And then I'm creating the cover group. Inside that I'm creating the cover point. So this is my address, this is my signal address. It will check the randomization whether the values are hit or not. Okay, so and then here in the run.to file I will change my uh, file name system test.sv, and then my simulation name is tb, so same like. So and then I'm open my system Costa Sim software, new terminal. So just type vsim here, it will open your it will open Costa Sim in your working directory. Okay, so ls, so do run.to, sorry, just a minute. CG over here. So Radhik, thank you for your response. So kindly post certain things. So I will share the attendance link now itself. Okay, so thank you for your response, Annamalai P. So I will share the attendance link with the username of Manikantan Ayyappan. So before going to that, I will just show my output. So after creating, so you can see here just a minute. So this is my code, this is my class, signal names are there, and then I am using the coverage cover point address, and then new function, it will create the memory for the cover group, and then so I am using in my inside the class only. So there is no need for the creating instance. You can create only memory for your cover group. So I am creating memory for that, and then by using the you can here I am creating the handle name and the memory name for my class, and then this is my repeat loop. So I'm doing 20 times of randomization, and then so I will just display my values also, display my values of every time of randomization. Deploy my values of address ADDR equal to percent. I want to see my output in decimal. So and then h1 dot ADDR. Okay, why I'm using h1 means h1 is my handle name of my class. By using that only you can access the class properties and methods inside your module, inside my simulation. Okay, so again I will just run. Just a minute. So this is my randomized output 2 1 7. You can see here 2 1 7 5 6 12 14 0 15 1. So I'm using randomC keywords, that's why there's no repetition happens over here. So this is my randomized values of signal ADDR. So to view the coverage, to view the coverage report, firstly you have to go to your view, click on view, and then go to coverage. Here in the you have to click over cover group. So then after clicking the cover group, and it will open new window like this. Okay, you can see the new window like this, and then here you can see here CG is my cover group name, type CG. So and then CVP, it means you can see here CVP, it is nothing but cover point. Okay, cover point name is, so just I will just expand my this. So cover point name this CP1. So you can see here my cover point name is also CP1. Okay, so and then you can see here I got 100% of coverage, 100% of coverage, and then my goal is 100, and then total number of percentages occurred means 100%. Why? Because of I am here. Firstly I will show you all the bins. You can see here bin auto 0, bin auto 1, bin auto 2, bin auto 2 up to 15. Why it will showing why it will showing bin means each and every value of randomization is a bins. So 4-bit means there is a value of 16 values. So it will create automatic bins of 16 values. Okay, bin 0 it's for 0, bin auto 1 it's for 1. So and then bin auto 2 for 2 value. So and then bin auto 3 for my 4 value. So 4 value of address. So totally it will create 16 automatic bins. Each and every value of the signal is bins. Okay, so why it will create automatic bin means you can see here bin auto, it means automatic bins. Why? Because of I didn't created explicitly bins. So user also can create the bins, but I didn't created the bins for signal. So I will show you how to create the user bins. Firstly it is known as automatic bins. The coverage report is 100%. You can see here status and 100%. Why? Because of that particular value is covered. Okay, for example if you take like a auto bin 4 means 5 value. So in the 5 value is occurred or not. So in my, if you see my output, the 5 is occurred, so that bin is occurred, so you got 100% of auto bin 5. So it will check each and every bin whether it is occurred or not, whether it is hitted or not. So this is a process of coverage. Okay, so this is a process of coverage, and then this is how you can see the output of coverage, cover groups. So firstly you have to go for view and then choose coverage and then cover group. You will see this window. This is how you can see the coverage report. So 100% of I got 100% of coverage report. Why? How I can get the 100% means my signal width is 4-bit only. Okay, 4-bit only. So totally you will get from 4-bit of 0 0 to 1 1. It means 0 to 15. But I am doing 20 times of randomization. So more than my bit value. So more than my bit I am doing randomization. Then that's why only I got 100% of coverage. So whether you can see here, if I give like a 10 randomization, it means that signal, that particular signal, it will get the value of 10 times only, 10 times of randomization. Okay, if I do 10 times means I will get only 70 to 80% of coverage. So I will show you that one, that also. So again I will do simulate. So in that, now I will get only 60 to 80% of coverage percentage only. Why? Because of I am doing only 10 times of randomization. Okay, so again you can see here 62% of coverage. Why? Because of I am doing only 10 times of randomizations. You can see here auto bin 3, auto bin 4, and then 8, 9, 10, 11, 12. So these pins are not hit, are not occurred in randomization. So why? Because of there is no sufficient randomization repetition. That's why it will give 62% of coverage. Okay, to check the functionalities of to check the all the signal functionalities means you have to randomize more times, then only you will get the signal stimulus for design code. So you can see here is some missing values like 9, 10, 14, 15, 9, 10, 11, and then 4. So this kind of values are missed, so that's why I got 62% of coverage. Okay, so sir, so thank you for response on Bharatraj Singh. So sir, I designed a circuit with the MOSFET and other elements like resistor. I got out that if VDT is increased, that will be current. So Radhi, so Kumar, I will come to that point later. So firstly, we will see the SystemVerilog. So so I will share the attendance link now. So just fill the attendance link. So I will share the attendance link with the name of Manikandan Ayyappan. So you can use that link for attendance, filling the attendance. Just a minute. So I shared the attendance link with the username of Manikandan Ayyappan. You can use the link, or else I will just post the link itself. Just copy that command and then paste in your Google. You can fill the attendance. Okay. So I'm sharing the attendance link with username of Manikandan Ayyappan, day 29. So just copy the link. So you can copy your link and then fill your attendance. So and then if you guys are really interested, you can convert this masterclass into 1 month of internship. So you will get the internship registration link in description of your live stream. So you can use the link for register for internship. So and then so Naveen Rathe is current increase or decrease? So for regarding this doubt, you can post, you can communicate with our pantechelearning website, or you can just call the pantechelearning support. So I will discuss with you. So before going to that, I will complete remaining topics. So this is a basic auto bins. So auto bin creation, coverage point, cover group, and then cover point. So we'll see the explicit bins. Explicit bins is nothing but the user add explicitly bins. So explicit means we are adding externally. So you can see here there is a same syntax: cover group name, some event triggering signal clock, and then cover point address. So you can see here bins. This is my explicit bins. This is my explicit bin name. So I am checking that I can give the values 0 to 0 to 7. So I am giving some specific value for my coverage. Okay, whether it is this kind of values are occurred, whether or else this kind of values are randomized or not. If it is randomized means, so your coverage, your randomization is working fine. So let's do this. Okay, so let's do this. So I'm just adding this coverage in my code. So this is my new coverage. So I will show you that. So here the bins is known as explicit bins. So now user we are adding externally bins. So in this cover group the bins are created by the tool only, tool itself. Here the bins are created by the user, so I am creating the bins. Okay, so just a minute. Okay, here I didn't have any signal, so for that I am using ADDR signal. Okay, so and then this is my first cover point, so this is my signal address, and then I am creating the bins over here. Okay, I am creating the bins over here. This is my explicit bins, it is my external bin. I'm creating that. This is my bin, this is my bin name, and then this is my bin values 0 to 7. So if it is occurred, if it is randomized, means it will give the 100% of coverage. If it is not occurred, it will give the some 50% of values only. So for example, so here I am changing this signal into integer data type. Why? Because of here I'm just doing with 160, 170, 180 values, so that for that I'm changing my integer data type. So integer means 32 bit of width, so you will get more values. So this is my explicit bins. In my here I'm creating the 3 bins 11 to, so here I'm checking from 11 to 20, so whether it's covered or not. So this is my bin 3, this is my bin 1, bin 2, bin 3, bin 4, bin 5, bin 6, bin 7. Okay, so here I am checking the more than 100, so more than 200. Here in the bin 5 I am checking that I am checking the 160, 170, 180 are occurred or not. Here I am checking that. So you can see here this empty box, in the empty square box refers to kind of array. In that it's like a dynamic kind of array. So like dynamic related to dynamic. So it will check 79 to 99, and then 1102, 130, 140. So it will check continuous values of randomization. Okay, so main thing is this is known as explicit bins. It means we can add the bins, explicit bins, user bins. Okay, so and then here I am creating only memory for CG. CG is my second cover group name, and okay, I'm only a sample. I'm creating only memory for CG, second cover group. Okay, so and then same thing. So I'm creating handle for my class. H1 is my handle for my class. Inside that I'm having the two cover groups. One name is CG, another name is small CG. Here I'm using the control signal like address. If the ADDR signal is any triggered means if it is got any values of 0 or 1 means this cover group are executed. So this is my first cover point. The cover point signal is address. This is my second cover point. I'm creating the second cover point WR read or write. Okay, so for now, as of now, I just created the two cover points, address and then read or write signal. So in the read or write, in the address signal I am creating the external bins. It is known as explicit bins. Explicit bins is nothing but user can give the values, can give the coverage values, whether is after that we can check whether it's occurred or not while doing the randomization. So we will see the coverage report on the simulator. So for that I just run again the code. So in the 11th line, CG is undefined. So I just change my name here CG, and then here also I'm changing name CG, capital CG. Okay, so and then I just run again. there is an error called user system like 11th line user define undefined variable CG 11th line. So I'll just cut copy over here, say CG. So and then SystemVerilog 14th line, just a minute. Everything fine only. I just command this to check my result quickly. So let's see the coverage report. Go to cover group and then click coverage and then click here cover group. So you will see the report like this, and then you can see here I got only 0%. Why? Because of I'm doing randomization only 10 times. So I just change my randomization. I'm doing up to I'm creating with signal randomly only, so I'm doing with 200 times. Okay, and then I will add my constraint over here. Constraint C1 is my constraint name. So why? Because of why I'm adding constraint means, so here I'm dealing with integer data type. Integer is a 32-bit of data type, so it will give the more randomized value. So that's why I'm writing constraint. So my constraint address is my signal. It will address less than or equal to 100 0, and then address greater than or equal to 500. Okay, so I'm giving the range between the 0 to 100 by using the constraint. Okay, so I'm checking that whether whether I given constraint values are randomized or not. Okay, so you can see here now I got 2% of coverage. So again I have to increase my repetition randomization of report, randomization of coverage. I'm giving randomization of 500 times. So let's check whether it is increased or not. So main thing is your constraint is very important, then only you will get the randomized output. Okay, so here I got only 2% of coverage only by using the coverage, this kind of coverage. Okay, so this is how you can use the coverage. So and then there is a lot of remaining topics. These are known as explicit bins. You can see here these bins are created by us only. Bin 49, bin 4, bin 4, and then bin 3. These bins are created by the us only. Okay, so and then this is a basic of implicit bin and then automatic bins. And then by using this bin transition, you can give the transition like a bin 2. You can give the value from 40 to 50 transition, and then 80 to 90, and then 90 to 100, And then ignore bins means you can give some values to to ignore the values while doing randomization or else while doing the coverage. Okay, and then we can set as a illegal bin in the coverage. And then we'll do cross coverage by variable name. So this is a remaining topics in the coverage. So and then we having the coverage options like at least, auto, bin, max. So and then attendance link. So I will share the attendance link with username of Manikandan Ayyappan. Just copy the link. Okay, so I share the link with the name of Manikandan Ayyappan to fill the attendance. Okay, so again I will share the attendance link. Okay, so or else if you can't able to fill the attendance means I will post the link. I will share the link tomorrow class. Tomorrow last class I will share the whatever you want links. I will share the link tomorrow. So if you missed today, okay. So then this is a remaining things of cross coverage, code coverage. Sorry, bins, auto bins, cross auto bins, max, and then at least. So this is a remaining bins. If you, it is a very easy only. You can learn yourself. The main thing is you have to understand the how the coverage is working. So okay, how that simulator will check the coverage reports. The main thing is randomization. We are doing randomization, and we are giving some limitation for randomization by using constraint, and then we are checking that that particular limited values are occurred or not while doing randomization. If it is occurred means that randomized values are given to design code, it will check that. So if for your design code you may use some specific, you may need some specific values to check your design. So on that time you can check that whether that values are occurred or not. If it is occurred means it is very good for us. Why? Because of that's the value we need for design. So we are checking that. If it is occurred means it is randomized, it is given to the design code. Then only we can finalize. Then only we can say like our design coverage is working fine. So our design code is working correctly. Okay. So we can measure the all the coverage part. So all the coverage of randomization. So this is a basic of coverage. So and then this for today. Tomorrow we are gonna see AXI full code with SystemVerilog architecture with the coverage, assertion, and then constraint also. And then this is for today. So we'll see tomorrow. So is there any offline training in VLSI Pantech? Yeah, we have training in Pantech, like a 2 month, 3 month course of VLSI. So in Chennai Chamanjari branch, you can come over there. You can register for your internship, and then training. Okay, training of 3 month, 2 month. So if you interested means you can come. You can reach out us. So tomorrow in the tomorrow session, I will share the mobile numbers for training and internship regarding things. You can call that number, or else you can go to our website. You can get our contact information. Okay, so thank you guys, thank you for your presence, thank you for your daily presence. So this is a basic thing of coverage. This is how we can check the output in the QuestaSim tool to see the coverage report values. Okay, thank you guys, thank you for listening. We'll see you tomorrow. Okay, good night. Ramachandru Naidu. Thank you for response, thank you for your presence, Vaishnavi. So Vaishnavi PV, I will share the link tomorrow. So okay, so I can share now, but you can't able to copy paste, I think so. So I will share the attendance link in the tomorrow session with the today attendance link and also yesterday attendance link. I will share the link in tomorrow session. So tomorrow is our last day of our intense masterclass. So tomorrow we'll go and see AXI code filled with the SystemVerilog testbench architecture, and then architecture with the coverage, constraint, assertion also. So thank you for your support. So thank you guys, thank you for your presence. So we'll see you tomorrow. Good night.